Did you know that beneath Antarctica's icy expanse, scientists have uncovered 85 newly discovered subglacial lakes? This groundbreaking discovery, revealed through a decade of satellite data, has reshaped our understanding of how glaciers behave and how they influence global sea levels. But here's where it gets controversial. Many experts argue that the true scale of these hidden water systems could be even greater than what we've mapped so far. Hidden deep within the largest ice mass on Earth, hundreds of subglacial lakes form a critical part of Antarctica's frozen landscape. These bodies of water, some stretching kilometers beneath the surface, play a pivotal role in shaping the movement of glaciers and, by extension, the stability of the entire continent. Researchers from the University of Leeds, in collaboration with the European Space Agency, ESA, have identified 85 previously unknown lakes surrounding the South Pole, bringing the total number of active subglacial lakes under Antarctica to 231, a nearly 50% increase from earlier estimates. The study, published in Nature Communications, is particularly significant because these lakes don't remain static. Instead, they fill, drain, and refill in cyclical patterns, offering a rare glimpse into the dynamic processes occurring at the base of the ice sheet. For instance, the research team observed 48 complete filling and draining cycles of subglacial lakes, doubling the number of such events recorded globally before this discovery. Lead researcher Sally Wilson explained that these cycles are notoriously difficult to track, often taking months or years to complete. We only had 36 full cycles recorded worldwide before our study, she said. Now, we've added 12 more, giving us a clearer picture of how these systems evolve. This is where satellites become indispensable. ESA's CryoSat satellite, launched in 2010, has been instrumental in mapping these hidden water systems. By measuring tiny changes in ice thickness and height, CryoSat's radar altimeter has provided a decade-long dataset that reveals how subglacial lakes expand and contract. These observations show that the ice sheet surface rises and falls as lakes fill and drain, said co-author Anna Hogg. It's like watching a heartbeat beneath the ice, something we've never seen before. But this isn't just about tracking water. It's about understanding how these systems interact with the environment. As Sally noted, current climate models rarely include subglacial hydrology, which is crucial for predicting how ice sheets will respond to warming temperatures. If we don't account for these lakes, our projections for future sea level rise will be incomplete, she said. The new data from this study will help refine those models, providing a more accurate picture of how meltwater flows beneath the ice. Let's dive deeper into how these lakes form. Subglacial meltwater is created by two main sources: geothermal heat from Earth's core and frictional heat generated as ice slides over bedrock. Over time, this water can pool on the icebed, creating lakes that periodically drain. When this happens, the water reduces friction between the ice and the bedrock, allowing glaciers to slide more quickly into the ocean. Not all lakes are active, though. Many are stable, like Lake Vostok, which lies beneath 4 kilometers of ice and holds enough water to fill the Grand Canyon and overflow by 25%. If Lake Vostok were to drain, it could destabilize the Antarctic ice sheet, disrupt ocean currents, and raise global sea levels. And this is the part most people miss. Subglacial lakes aren't just isolated pockets of water. They're interconnected networks, like the 5 subglacial lake systems identified in this study. These systems act as conduits for meltwater, influencing everything from ice flow to marine ecosystems. As Martin Waring, ESA's Polar Science Costa Coordinator, put it, understanding these processes is key to predicting how the Antarctic ice sheet will respond to climate change. So, what does this mean for the future? Scientists are now debating whether the true number of subglacial lakes is even higher than what's been mapped. Some argue that the CryoSat data may have missed lakes in certain regions, while others believe the findings represent a major breakthrough. The question remains, will these hidden water systems ultimately stabilize or accelerate the loss of Antarctic ice? We need your input. What do you think? Share your thoughts in the comments below.